Guys, today's video is overview of PLC wiring as well as a relatively simple program. I'm going to be wiring up and demonstrating a program on my PLC workbench. I hope you guys enjoy the video. Thanks for checking out the channel. Go through a quick review of the wiring with you guys. So you got 120 volts coming in on the circuit breaker. Goes right here to a 24 volt power supply. And I'm using that 24 volts to power my PLC right here. Power goes in right there. This is my output to the conveyor. So CM0 is 24 volts going in. Then that 000 is that first discrete output, and we are fusing that circuit going to the conveyor. So that is the circuit that powers our conveyor. It wraps around under here and runs the motor back there. There's also another fuse that supplies the PLC. We got to fuse our PLC. Then over here, these are our discrete inputs. Hold on. These are all 24 volts. So input 4 is the start button, input 5 is the stop, 6 is manual mode, 7 is auto mode, and 8 comes off the sensor. So 4 would get 24 volts right now. Input 5 always has 24 volts. When we push that, it loses it. Input 6 gets 24 volts there. 7 gets 24 volts there. And input 8 gets 24 volts when we block the sensor. This is a 5 volt sensor. You can hear that relay clicking. 24 volts comes in one side and goes out the other. And yeah, I forgot to install DC minus right here on COM 0. So I'm going to go ahead and do that right now. On your comms, they behave differently on inputs and outputs. These inputs, you get 24 volts coming in, and then, you know, your load is inside the PLC, and then it comes out on DC minus. Not to be confused with your outputs, where these outputs are just like a relay switch, like a contact. These outputs just go like that. So you want 24 volts, you want your power on one side, and then your power comes out. What I do is I'm going to write a little bit more of a complicated program. Basically, what we're going to do is we're going to use our automatic mode. And when we're in automatic mode, manual mode, when I hit start, the conveyor will run until I hit the stop button. And if I go into auto mode and then hit the start button, it will activate everything. And then once I hit our sensor here, it'll run for, 5 seconds, and then it will stop. Yeah, that's what I'm going to do. I'm going to write that program up real quick, and then we're going to test it out, and this video will be over. All right, now let's write some code. Okay, so write ladder diagram. You go under Project Organizer, right-click Program, Add, New Ladder Diagram. Then you double-click on Program 1. Let's get this started. All right. In case anyone's curious, this is a Dell Latitude computer. All right, so here's the program. When we're in manual mode, we hit the start button, the conveyor will run. Let's add a rung right around this guy. This is called a sealing rung. Oh, it's not letting me do it. Oh, come on, you little bastard. There we go. And then so manual mode, start button, conveyor will energize, and then that conveyor running will hold this circuit closed. So we'll get green here, and it will run across that top line, but then once that's running, you'll have an alternate path. This is the input of the conveyor running, and that will keep it running. So let me put this here, and we'll call it conveyor. Right? Okay. That stop button is always sending 24 volts because it's normally closed. So we're still going to have a examine if closed, our normally open symbol. Because this stop button is always green. When we're in manual mode, this is always green. We hit start, we'll get our green, we'll run across, turn on that conveyor. Once that conveyor starts, our path will be right here. And then when we push that stop button, that will interrupt that circuit and the conveyor will stop. Now we need to add another one, another branch. How do we do this? Maybe like this. Hi-ya! Yep. Then this will be for our automatic mode. Well, we'll have to do let's do a latching bit, because we want to wait till after we hit the start button. We don't want this thing to start on its own. So I'm going to say start. And then I'm going to add in here. No, I don't want that. I'm going to delete that. I want a set coil. I guess that's the same as a latch. We need a bit. Let's use this unused digital output 3. So we'll activate digital output 3. If the stop button is pushed and it's not active, so when you push it, it's 0 volts. So when you don't have stop, we will unlatch that same bit. Set release, I guess, latch on latch. Why not? Probably means the same thing, right? I'm gonna guess it does. Okay. So if we're in auto mode, we hit the start button, this DO3 will become active. If at any time we push the stop button in, that DO3 will become inactive. And down here, if we have DO3 active and that timer or that sensor is pushed in, we're going to energize a timer. See, I told you guys I'm brand new to this. There's got to be timers. Yep, there we go. Timer off. So if we have this DO3, which we're using to be like auto mode active bit, if we have that DO3 and we hit that sensor, we're going to turn on our time off delay. We'll use that time off delay to run that conveyor for 10 seconds while the time off delay is counting down to turn off. We will run that conveyor, and that's how we're going to do it. But all right, I figured it out. So what you do, this box on the right here is the elapsed time. Here's your set point over here, PT. So you do T # 5 seconds. Enter. 5S. So we got a 5-second time off delay timer. So when we get that DO3 output, which we're using like a bit, I apologize, guys. In a normal, PLC programming, I would use a bit. I don't know how to do that yet on this software, but we'll get into that later. This is just like a basic beginner level video. So if we get that bit and we get that sensor, we're going to start this timer and it will take 5 seconds to turn off. So I'm going to try it. I'm going to test it out. All right, so there's our program. Hit this sensor. We're going to energize this timer. And as this timer is active, the conveyor should turn on. Then we will lose this sensor input and we should run for 5 extra seconds. I'm actually not sure if this is going to work. I'm getting a little confused. Let's test it out together and see what happens. So now I'm going to have to go, I believe I got to connect and download. That's what I'm going to have to do. All right, guys, so I have very interesting results. So when I go into manual mode, you see it light up right there, and I hit my start button, the conveyor doesn't want to turn on because we have that same output on a different line of logic, a different rung down here at the bottom. But when I put everything into automatic mode, my stop button, it takes out the latch. Now I'm going to hit my start button, and that bit, auto mode happy, comes in. And if I block my sensor, it works just like we wanted it to. You see it counting down. Boom. So I'm going to have to combine those two rungs onto the same line of code with the same output. So I'll just have to put an OR branch with this logic on there. Basically, I'll have to combine this line and only have one output for a conveyor. And I believe we'll have a great success, boys. So I made an OR branch. I'm putting all this stuff inside of it like that. I just have to copy this branch. So we have a normally open for manual mode. Sorry, examine if closed. I say normally open because that's what it is on electrical schematics for the start button. And then the same for our stop button, because our stop button is always 24 volts. It's always active. It's wired backwards from everything else. Our stop button. Stop, normally closed. So when you push that in, you lose that voltage. And we just got to do a ringy dingy rungy dungy down here. Oh, that worked. And we'll just put the conveyor running here. Oh, I made an extra one. Come on, baby. Be good to me. All right. So that's the conveyor. And then we'll delete this one because it's extra. Delete. All right. So auto mode and start. It gives us DO3. If we hit sensor 1, we energize the time off delay timer, which becomes active immediately. And it will stay active for 5 seconds, which will turn on our conveyor. Or there's the OR branch. For manual mode, we hit the start button. Stop button is just left alone because it's always active. That will start the conveyor, and that will seal in that circuit. So if we're in auto mode, we'll run on that rung, and if we're in manual mode, we'll run on that rung. All I gotta do now is delete this rung, connect to my controller, which has proven to be a pain in the butt. Download the current project to the controller. Let's go. All right, so here we go. This is off. Nothing happens. Auto mode. Wait a second. I gotta hit the start button. You can see the power for my conveyor is actually coming through this relay right here. Forgot to mention that. You don't really want to power motors directly from your PLC output. So I'm using this output to energize that relay, and then the power for the motor is running through a fuse and then, to that motor. And then normal mode, manual mode. They call these switches hand, off, auto switches, HOA, or hand is like manual. Manual mode, start. Stop. Start. Oh no, my hair's stuck in there. We got it, baby. It's that simple. Oh, my hair. Boom. That's it, boys. Look forward to us adding color sorters to this, conveyor setup, pneumatics at some point. I don't know. Get creative with it. If you have ideas, put them in the comments. If you watched this far, thanks for watching, guys. Hopefully this is the beginning of a whole new era of the channel. I hope you guys like it. Again, controls technician, electrical technician, instrumentation technician, industrial electrician. We fix circuits, we program PLCs, we troubleshoot big, expensive $1 million machines, and it's a great career. I love it, extremely high demand. And whatever the demand is now, it's about to double because most people are retiring. So look into it, guys. Thanks for checking out the channel.